All right, we're going to try this again with barking dogs and ringing phones and stupidity. We just had to build the supply. Notice I said we had to build it. It's not something we wanted to build, but the issue was we were using this old analog guy, and we've gone through a couple of them. And this one blew up in such spectacular fashion that it took out my Kenwood, my amplifier, several coaxes, piece of test equipment. When it shorted, it shot several hundred volts back out its output to all my equipment. So now my amplifier is blown up. We're going to fix that. We're going to have to send my Kenwood off to the Kenwood guy. And my response to that is this. I never really wanted to get into making power supplies, but we kind of had to in this case. So we took a couple of these 30 amp supplies. Now, I like being able to adjust my voltage up and down. Okay. The thing is, if you're going to do it on a supply like this, you've got to make both. You've got to make both of these banks go up and down simultaneously, or they're going to fight with each other. So we came up with a circuit. I went in, I tapped the reference, the low voltage reference, which is this section, not the high output section, not the high output part over here. We went into where this is telling it what voltage to stick out of its high end, okay? And that's what we manipulated. However, we found a way to do it on both packs with neither pack interfering with the other. Once we solved that problem, we could get it all the way up to 14.5, 6, take it all the way down, 10 even. Now that's on both packs that it draws that up and down. What you're seeing is an accumulated voltage from both packs. So now, this control's a little touchy. We're going to do something with that. So now also, the current meter. We cut out the current meter from the original pyramid that this originally was, mounted that section here, and just basically plugged the meter back in and wired it in the way it was wired in the other meter. We also have some big resistors isolating the big outputs of these so that the outputs don't become unbalanced. On top of that, there's 10,000 mics of storage on each bank, along with another 10,000 mics of storage on the main output. Now, this thing that's hooked to is what's going to keep the supply alive in this environment. We do a lot here with RF. RF will get into anything it can, through any line that it can. So what we've done is on these main four come together and they go into this very high current RF choke. So if any RF comes off whatever device we're working on back through the DC lines, it's going to stop right here and not get into the rest of our unit. Okay, so that's okay. So that's what we came up with. That thing's going in the trash. I don't even want its parts. We have one commissioned to be built, and this one ended up being practiced, not out because I wanted to practice, but because my entire bench got blown up. So that's where we're at. So now I've got to send a Kenwood off, rebuild my amp, make all new jumpers, but we've got the main problem fixed, which is a nice, clean, stout supply, good for 50 amps realistically, but with a variable voltage, current amp meter that works properly, and RF suppression to boot. So we didn't want to get into the power supply market, but after watching 2 or 3 of them blow up here in the last 2 or 3 years, nothing else I build blows up, so I figured we might as well start building power supplies. Now, the only thing that really makes this one different than any other one is, and I don't even know that it's all that different. I personally have not seen it. Nobody that I know has ever seen it done, where people use multiple packs and manipulate multiple references with a single control without these two fighting with each other. It's kind of a nifty little trick to pull off. If it has been done, I don't know if they do it the way I did it, but it does work. So this gives us 10 to 14.5, 14.6 at 50 amps solid all the time. And I hope it's going to be a decent bench supply as I get this. Fans, that's what I didn't go over. You know, when you guys see these, they have a cover on them and the fan's inside. So this fan was already in here from the original power supply. What we did was we took the pigtail off the lid fan on this one, attached it to this one, so when this one thinks it's getting too hot, bam, this one's going to automatically turn on. We're also going to take the other one off this cover, flip it upside down and mount it to the bottom of the top cover, and plug it back in so that when this thing feels it needs air, air will move. So we're going to have two circuits controlling air circulation inside the box. And that's the way it goes. That's the way we're in. Now I guess I hope I can find the lid for this thing. So I pulled it out of the parts pile, gutted it, and built it. Don't even know if I got a lid for it. No, I am not leaving the coax connectors in. The coax connectors will be going on all the brand new RG213 I got to make because it got smoked. So there it is. 409 radios came up with our first power supply. Multi-bank, singular switching, RF protected, 50 amps plus on a blink, no problem. I would guarantee this to anybody I'd sell it to. We are getting ready to build one, and this was commissioned before we built this. The gentleman needs 150 amps plus, and he wants it dialable. He wants a variable voltage. Well, he hasn't been able to find anybody to do it for him. I said, well, let me see what I could pull off. So before I could even get to building, his parts came in while I was building this one. So we basically use this one as practice for our manipulation circuit to control the references. To get these supplies to go where we want to go. Mine is a mere 50. His is going to be 160 plus. So I hope he sees this video and likes what he sees, because his ain't far off from being this one, other than the fact that we're not going to put a current meter on his. He's going to have a digital meter. He'll be able to dial his voltage up and down, and 150 amps plus on tap. So there it is, 409 Radio's first attempt at a decent power supply. And as usual, we didn't do anything the way anybody else does it. RF suppression, stiffening and cleaning caps, you know, keeping the signal not dirty, no hissing, no buzzing, and keeping it stiff. And then a final one on our output, RF suppression. Automatic fans, digital voltmeter, reading the output. Now this meter is reading what's going on here. Not what's going on here, not what's going on here. It's reading the combined result of what we get out of that choke. And whatever comes out of that choke is this number at 50 amps plus. So there we go, guys. There it is. I hope it works as long and as good as it looks. 7.3s. Now you can get back to work. Put this thing in line and fire the benches back up and get back after it. So 7.3s, wash your hands, and we'll see you.